Good evening all. Myself Harshra Minhas, PhD scholar at the Department of Chemistry IIT Indore. So I'm taking your PMRF TA course of Introduction to Chemical Thermodynamics and Kinetics of course code as NOC23-CY38. And today we are going to do some questions based on your this week conceptual knowledge. So let's wait for another couple of minutes and then we can start today's session. Okay, so before dwelling into the question sessions, let's revise the formulas that we are going to use in this assignment questions. Okay, so the first law states and gives you equation of du equals to del cut w plus del cut q. So this is in the differential form. So in the integrated form it will be u plus w, where this heat, this work and heat are the interexchangeable quantities which are based on their path functions and the path that they follow, and this q can be represented by mass into specific heat into temperature, into change in temperature. So from here, this first law and the concept of integral energy, which states that if the system is subjected to any cyclic transformation, so like from P1 V1 to P2 V2, then it's going to its initial state to the final state, and it's following a cyclic process, and that we call it as an expansion or this as a compression. Then the work processed in the surrounding is equal to the heat withdrawn from the surrounding itself. So it depends upon the heat exchange between the system and the surrounding, and then according to that, this compression and the expansion processes are taking place. So now we state that the U, that in energy, the changes in the state of energies is a function of volume and temperature. So according to this function, we state that du, so from here we get the term constant volume. So by deriving all the equations, I will straightaway going to write the overall formula that we get, that is heat capacity that is denoted by Cv by del cut Qv, that is at a constant volume with respect to dt, and this we can state it as a du upon dt at constant volume. So after differentiating these terminologies with respect to the volume and the temperature, each at a one step, and then after reducing it at a constant volume, we get du upon dt at constant v. So similarly, keeping the energy, this u, with a function of pressure and temperature, and again expanding the differentiating terms with respect to pressure and with respect to temperature, so we get heat capacity at constant pressure, and we state it by Cp. And from here we denote del cut Qp upon del T is equals to del H upon del T at constant pressure. And further we can also get the enthalpy equation, H equals to U plus PV. So change in enthalpy we can state Cp is equals to the delta H is equals to Cp upon d into dt equals to So this delta H is equals to delta H, that is change in enthalpy, that is equals to Cp into dt plus dH upon dP at constant temperature into dP. So similarly we can state the change in internal energy, that is du is equals to Cv into dt du upon dV at constant temperature into dV. And then we know this equation, that is the relation between Cp and Cv, that is Cp minus Cv is equals to R. So when your number of moles, that is your N equals to 1, so if when your moles are not 1, then we can state it as these are at a molar value. So when your N is not 1, then Cp upon minus Cv is equals to Nr. And then we have read about the Joule-Thomson coefficient, which is denoted by mu Jt is equals to dt upon dP at constant enthalpy. And then the most important equations that we gone through is adiabatic change in state. So from here we get the three main equations which shows the relation between the pressure and the volume and temperature, and volume and pressure. So these are the equation at the adiabatic change. So these are like temperature into volume with the exponential of gamma into gamma minus 1. So we can use it as T1 V1 gamma minus 1 equals to T2 V2 gamma minus 1. So from here we can find the unknown quantities which are being asked. And this next relation is PV gamma, PV to the exponential gamma, and that is PV gamma P1 V1 equals to P2 V2 gamma. And third one is T to the power gamma and P to the power minus gamma. So similarly this can be used as so these are the basic formulas that you have read in this week. And one more thing, about the degree of freedom. So from here we have studied the linear and the non-linear molecules, that is your N, and you have read your linear and the non-linear molecules. So for the linear systems, so we state that there are three translational motions, and then two rotational, and the remaining so here we are considering N, So that is the n total motions, so n, and then these are your remaining vibrational motions. So for here there are two rotational motions. Why we are saying it, there are three axes, that is x, y and z. So along the y-axis, along the one axis, suppose here is your molecule carbon, and along the one axis your moment of inertia is not changing, but your moment of inertia is changing when your molecule is getting along the x-axis or along the y-axis. So that's why we have considered the two rotational motions, whereas in the non-linear molecule we considered three translational motions and three rotational motions, and the remaining, that is these two, are in addition. So adding these two makes 6 and these two makes 5. So here we are subtracting 6 out of the total, and the remaining are showing us the vibrational motions. So according to this, we can use, for the vibrational nodes for the linear molecule, we can use 3n minus 5, and for non-linear systems we can use 3n minus 6 to get the total vibrational nodes in that molecule. Okay, so now move into the question sessions. So here is the first question. So it states that the 1 mole of an ideal gas is allowed to expand from state 1 to state 2 by two different paths. In the path 1, the Q is equals to 10,000 joules and W equals to 0. In the path 2, the Q given is 15,000 joules and W is equals to 0.5 of W max. And estimate the magnitude of work if the process occurs reversibly. So here two paths are given. So in path 1, if we follow the path 1, and the equation that we are going to use, yes, if someone has any problem, yes, can speak.
Madam, answer is A, I think. The answer is A.
Yes sir, it's A, and if any other person has also solved it, please let me know, and answer and give your answer in the comment box.
The net work done is equal to net heat absorbed, I think. Basing on that principle, we can solve it.
Yes,
And
yes, exactly sir, exactly.
thank you, madam.
So yeah, it's option A. Okay, let me solve it for others. So this is the equation that we are using, the first law equation, and for the path 1 we have Q is equals to 10,000 and W equals to 0. So from here W equals to 0, so we can state that our del U is equals to Q, that is 10,000 joule. But for the second path, our del U is equals to So here, to get the overall work done, we are subtracting this 15,000 value that is in the path 2 minus for 1000 joules, that is for work we are going to get 5000 joule. So from the path 2 now we are getting the value of 5000 minus 5000. And in the equation there is given that our work is equals to 0.5 of W max, right? So here for W max we can find it like this by putting the value of W that we got is 5000 upon 0.5, and we are getting minus 10,000 joule. So yes, so our answer is A, option A. So I hope everyone is getting the option A. Okay, let's move to the question second. It states that the 5 moles of an ideal monoatomic gas initially at 546 Kelvin and 10 atmosphere is allowed to expand adiabatically until the pressure falls to 5 atm, and calculate the final temperature, work, del U and del H, and this gamma is given for the monoatomic gas. So here we have to find the final temperature, that is T2, and then work, then del U and del H. So the parameters that we are having is temperature 546 Kelvin and the pressure P1 that is 10 atm, and then we have to find the temperature T2 and then find the pressure. No, pressure is given, that is 5 atm. So here, so which formula we will use to find out T2? So in the last slide we discussed about the equations which are used for adiabatic systems, like here. So these are the equations that we use for the adiabatic systems. So here we are having the pressure temperature T1, pressure P1 and pressure P2, and we have to find this temperature T2. So we are going to use this equation. So I can arrange the equation in this manner. And we have given this gamma, that is pi by 3 for monoatomic gas. So by rearranging all these terms, I'm written in T2 upon T1 equals to P1 upon P2 to the power 1 minus gamma upon gamma. So now putting all the values over here. So our T1 is 546 Kelvin, P1 is 10 atmosphere and P2 is 5 atmosphere, and our gamma is 5 by 3 upon 5 by 3. And please calculate it and let me know the temperature. Okay, 413.8 Kelvin. Any other option? Okay, so the answer is 413.8 Kelvin 42. Okay, so now let's see, check this temperature. uh, the options given are 413.8, 4, 4 and 413.8 Kelvin. Yeah, so these two options are ruled out. So now we left with two options, that is 413.8 Kelvin and 413.8 Kelvin, the A and D option. Okay, so now move to the next part, that is work del U and del H. Okay, so before getting into the work, let's find out the del U. So our del U, it can be stated as okay. So can we get the CV out of this gamma? So is there any way that we can calculate the CV? So N given is so the given N is 5.
Madam, Cp by Cv is equal to gamma.
Yes.
So from that we can calculate Cv.
Yes, exactly.
Because Cp is because you have already given gamma.
Yes.
Yes, and you can calculate the Cv from that.
Yes. And Sandeep is also mentioned correct, that is CV equals
And
to
this is, Cp by Cv is equal to gamma. That is the ratio is gamma is equal to Cp by Cv. So divide by Cv, then we'll get gamma minus 1 is equal to 1 by Cv.
yeah. So this is the equation. Can we use this? Now put the values in values over here and let me know the value of CV, and respectively calculate the CP also. Sir, I request you to please switch off your mic. Okay, simply put the values of gamma over here and you will get, so your gamma is, for monatomic system, your gamma is 5 by 3, right? So put the value of 5 by 3 over here, minus 1, and take the 3 as LCM, and 5 minus 3 is 2, and 3 by 2 R. And for CV and for CP, you have the equation CP minus CV equals to R. So accordingly, CP is equals to R plus CV. So now add this term that we got, that is 3R upon 2, that is R plus 3R upon 2, and we are having CP is equals to 5R upon 2. So your N is 3 mole, and you calculated CV is equals to and your temperature is T2 minus T1, and now you are having your calculated temperature. Four 413.8 minus 546 Kelvin. So now try to calculate this value and let me know the value that you are getting.
Madam, is it 4988.4 joules or 4.98 kilojoules?
So let me check the values. Values are given in calories. So make sure the R value that
Madam, N value you have given as 5 mole, madam, not 3 mole.
Oh, I have written 3 mole. Oh, sorry, it's my mistake. It's 5 mole. Yeah, it's 5 mole. No, I mentioned 5 over here and I written 3. Okay, yeah, 5 mole. So please use the value of R in that is in calories. So all the values that are mentioned are in calories. So use that term, use that value, and let me know the value of W.
It's 1987 calories, madam.
Okay.
Or 1987 calories.
So it will be negative, right?
Yes, negative.
Negative.
Because it is adiabatic, delta E will be negative.
Yes. Others are also getting the same answer. So please put your answer in your comment box. So what is the value of W that you are getting? So it will be approx. I'm taking your values. So it will be near to minus 1970 or yeah, it's negative, uh, near to this 1970 calories. Now check back the questions options that are given. So the options are all same, that is minus 1983, that are very close. Then mm, so we can't eliminate any of the options. So now let's calculate, sorry, we calculate the del u. For the del u we are having the two options, that is minus 1983 and 1983, that is option A and option B, these values. So yes, so from the first, that is the temperature that we calculated, we were getting the options option A and D, and now after calculating the del u we are having the option A and B. So therefore we got our answer, that is option A, I think. So now let's try to find out the remaining quantities also, that work and del H. So which equation we are going to use for work? So we are using this equation. Okay, so our Q is 0 for the adiabatic process, so that means our W is equals to del U, so that is the same value that we got, right? We got minus 1970 calories, right? And the last part left is del H. So can we use this equation? So this is the same equation that we got for del U, that is at constant volume. So now we are calculating at a constant pressure. So in the last slide we calculated the value of Cp, that Cp is equals to 5R upon 2. So now putting the value over here, now we are having 5 moles N, and our Cp is 5R upon 2 into the change in temperature. Now calculate it and let me know the values in calories. Okay, I got one answer. The del H is minus 3283.5 calories. So I hope everyone is getting the same. So our option is, so for the work we are having the same value of del U and this minus 3305. So option A is correct. So if we are having these kind of multiple options, we can go by the elimination method also to reduce our time. So for descriptive type of questions, so definitely we have to solve each and every part progressively. So yes, option A is the answer. Okay, let's move to the next question. Okay, it states that the 100 liter of an ideal gas is allowed to expand isothermally against a constant pressure of 1 atm until its volume becomes doubled. Calculate work, heat, del U and del H.
Madam, this answer is D, madam.
Okay.
Answer is D, madam.
Okay.
That is W is equal to minus 2421.3 and Q is equal to 2421.3 calories. Delta E is equal to delta H is equal to 0.
Okay, minus 2413 calories.
Yes, minus 2421.3 calories. W is equal to.
Okay.
And Q is also Q is a plus 2421.3 calories. And delta E is equal to delta H is equal to 0. Both are 0. Because isothermal process, delta E is equal to 0, so therefore delta H is also becomes 0.
Okay. Okay.
So the option is D.
Okay. So I got an answer, that is option D. So any other one who wants to explain this question? Anyone else who want to explain this question? Okay. So this is not an adiabatic process, this is an isothermal process. Okay. So in isothermal process our Q is never 0. Okay. So now we calculate this work. So in the last previous sessions also we used in this formula. In our last session we saw so many questions based on this formula, that is W equals to minus P external Vf minus Vi, that is final volume minus initial volume. So now the volume given is, suppose our volume, initial volume is Vi and Vf is your final volume, and it's given that it becomes double, that is twice of your initial volume. So now putting this value here, so you will get minus P external into Vi. Now see, so your volume is 100 liters and pressure is, and the constant pressure, this pressure is 1 atm. Now putting these values over here, so now this is in liter atmosphere, and now we have to convert into calories. So now we are multiplying by the factor 24.2 calories upon liter atmosphere. So after calculating this, we are going to get the values around to minus 2420 calories. So this is your work. So for the Q, we have equation W equals to del U plus plus Q, and now we have these values. Now put it here. So for that we require del U. For the isothermal processes, our del U and del H both are 0. So as we are having the constant temperature for an ideal gas, we considered our del U is equals to del H, that is equals to 0. So after putting the value 0 over here and then changing the sign, we are going to get 2420 calories, that is positive. Now go back to the options. So now we are having W equals to minus 2420 and this plus, the sign is reversed now, and in calories, and your del U and del H is 0. So our option is option D. Okay, moving to the next question. Okay, it states that the 5 decimeter cube of oxygen initially at 127 degrees Celsius at 1 megapascal expands adiabatically against a pressure of 100 kilopascal until the volume becomes double. Calculate the final temperature, work, del U and del H, where given is your gamma, that is 1.4. Okay, try to solve this and let me know the temperature first. Okay, before proceeding the question, we have to find the N, that is number of moles. So we have the equation. So by putting in this equation, so now we are having the pressure of 5 decimeter cube. And what will be the unit if we convert this decimeter cube into the meter cube? So it will be 10 to the power minus 3 meter cube. Sorry, this is the volume. This is volume. And temperature is 127 degrees Celsius, and to converting into Kelvin, what it will be? Kelvin, right? And the pressure is 100 kilopascal. Now converting into the pascal, how much it will be? 100 into how much? 3. Okay, now we are having your volume V, temperature T, R, and the pressure. Now putting into this equation, so what is the value of N that we are getting? So yeah, it's a 1 megapascal, yes. That is a P external. So now we have to consider this pressure, not this pressure. So by taking the 1 megapascal, so mega is 10 to the power 6, or this will be 10 to the power 6 pascal. So after putting this in the equation, so what will be the value of N? Yes, it's 1.5 moles. Okay, so now we are having the value of N with us. Now let's find the work first. That will be P external Vf minus Vi. For the isothermal processes, this is the work formula that we use. Now we are having the P external.
Madam, one question, madam. Shall I ask you one question, madam?
Yes, please.
Madam, we have initial volume as 5 dm cube and final volume will become double, that is it becomes 10 dm cube. And we have the temperature 127 initial temperature, and using the relation TV to the temperature volume relationship, that is TV to the power of gamma minus 1, can we calculate the final temperature in that way?
Yes, of course we can use that formula because it's a adiabatic process, so we can proceed in that way.
So if we are doing in that way, then the final temperature we are getting is 303, madam.
303.
Yes, madam.
Okay, let me calculate the this value, then we can proceed further.
Okay.
So let me calculate it.
Yes. Okay, madam.
Yeah. Okay, so while putting this value, that is 10 to the 5 pascal, that we calculated just earlier, that is 100 kilopascal it was given. The so what will be the change in the volume? It's given is 5, initially it's 5, then it's becoming double, so that means Vf is equals to 10, Vi equals to 5, and after subtracting these two, I'm directly writing the 5 and convert it into the meter. 10 to the power minus 3 meter cube. So our final work is minus 5 into 10 to the power 2 joules. Calculate temperature. So we got the work as 500 joule, that is option A, option B and option C. So now calculating the TF, so for that we are using this formula. So this is the mole that we get. Our CV is 3/2 and so this whole will be equal to your work that we calculated, that is minus 500 joules. So from here, by comparing this, we can find the value of TF. So what is the value of TF from here? So this is going to be 26.67 Kelvin. But our final temperature should be the sum is should be greater than your it is changing after your TA. So we have to add your initial temperature to your TF, that is final. So now adding your initial temperature, that's given. Now adding the initial temperature 127 degrees Celsius, that is 400 Kelvin, to this equation. Now the final temperature we got is 373.33 Kelvin. Now getting back to the options. Now for the temperature we are having the option of 373.33, 37 and again 3733 and 37. So our option that matches with this is 373, this value. And for the work that we calculated was 500 joules. Yeah. So I think it goes with the option A. So let's find out the remaining quantities that we left. So we find out W, del U, W del U and your TF temperature, and we left with del H. Yes. So now W we calculated is 500 joules, and our del U is equals to minus 500 joules by keeping the Q equals to 0 and then getting this del U. So now calculating the del H, that is NCP T2 minus T1. So now putting all the values over here and just calculate the value. Okay, instead of CP we write instead of CP gamma and CV?
Ma'am, in the previous case for delta U calculation, you took the CV
Delta,
value
sorry,
as
delta U.
for yes, ma'am. No, no, yes, ma'am. For delta U calculation, you took CV value as 3 by 2 R. Yes, yes, ma'am.
So this is
In
1.4. This is 1.4.
yes, ma'am. So for this, actually CV value will not be 3 by 2 R, no?
What I
Uh,
have written,
for,
it's by 3 by 2, the division of 3 by 2, what it will be.
uh, Actually, CV is 3 by 2 R for monatomic gas. For
Okay,
monatomic gas, we have gamma value equal to 5 by 3. So it is 1.67. But here gamma given is 1.4.
1.4, yeah.
So if we are calculating
Hmm.
CV equal to R upon gamma minus 1,
Hmm.
then we are getting 5 by 2 R. 5 by 2 R.
This will
Uh,
be 5 by 2 R.
5 by 2 R, because it will be 1.4 we will get only when gamma equal to 7
So
by 5.
what is the answer
7.
you are getting? What is the value
So,
of TF?
so for delta T I am getting
Delta
minus,
T
yes, delta T means TF minus TI value. TF minus TI value I am getting minus 16 kg.
minus 16.
Yes, ma'am.
So what I am
Because
getting?
yeah, because here yes,
Okay,
what you
26.
got minus 26 now, there I am
Yeah.
getting exact minus 16.
Okay. So you are keeping 1.4, right?
Yes, ma'am. So it is 7 by 5. Here gamma is 7 by 5. So we have to take CV equal to 5 by 2 R. Because for CV we have formula na R upon gamma minus 1. CV
Hmm.
equal to
Hmm.
R
Hmm.
upon gamma minus 1.
Hmm.
So if we are doing R upon 1.4 minus 1, it will come R upon zero point 0.4. So zero point 0.4 uh, uh, is equal, it will give 2.5 R. 2.5 R is the same as 5 by 2 R. So because it is this gamma value correspond to diatomic gas, not for
Yes.
monatomic gas.
Hmm.
So in that case, so in that respect, then the option will not match. Option will not match.
So what are the options for
Uh,
temperature?
because when we are adding minus 16 to 400,
Then
then it will
definitely it will
be
not be 373. Yeah.
yes, ma'am. Yes, ma'am.
It will be
So
383, I guess. Yeah.
yes, ma'am. So it may happen that they may have given answer based on monatomic assumption, but here gamma is 1.4.
Yeah, maybe. Exactly. That's why the solution is like considering the monoatomic value, not this value.
Yes, ma'am. Yes, ma'am.
Okay. Okay. So you are for with respect to 1.4 gamma equals to 1.4. You calculated your CV by 5 by 2.
Yes, ma'am.
5 by 2.
Yes,
Okay.
ma'am. 5 by 2 R. 5 by 2
5
R.
by 2
Yes,
R.
ma'am.
Yeah. 5
Yes,
by 2
yes,
R.
ma'am. Yes, 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 ma'am. R is already written there,
Mm-hmm.
8.314,
Yes.
so no
Yes.
need of writing.
Yeah.
Yes, ma'am.
Okay, anyhow, our value should be between 37. We are only having two options, 37 or 373. So if we are getting 383, then also we have to go by the option, the same options, right? But yes, I will look into this. Okay. But yeah, but I think they have in this solution they have considered this monoatomic value, not this gamma value. Okay. So what will be the value of delta H that you are getting? Yes, someone raised hand. Mohit, yes. Okay, what is the value of delta H that we are getting? Yeah, you can ask the question. Yes, Mohit, you are having any doubt? Okay, okay, got it. Now calculate the value of delta H and let me know the answer. So now can we write it in this way? This is del T. Now converting this Cp in terms of Cv, and then take this is molar quantity, right? Now cancelling the n and we are getting Cv into dt. Now Cv into dt, that we name it as du. So now using this terms, now we are getting, so 1.4 we have given, now minus 500. Now multiplying this value, that is minus 500 into 1.4, you will get minus 700 joules. So I hope this is the value that you are getting, that is approx value, that is minus 698 joules. Yeah, so it's round about to this 700, right? Okay, so this is 700 joules. So now our option is option A. The temperature final, the calculated temperature is 373.33 Kelvin with the work minus 500 joules, del U minus 500 joules, and del H minus 700 joules. Okay, moving to the next question. Yeah, Mohit, do you have any question? Any doubt?
Madam, the option for this question is B, madam, 0.96.
Okay. Okay, yeah, option, it's correct. It's a correct
Because
option.
the fall in temperature is 20 K and the fall of pressure is minus 21 atmospheres.
Okay.
So dou T by dou pH becomes mu Jt.
Correct.
Minus minus which cancels, it's nothing but 20 by 21.
Yes, correct. So yeah, it's a Joule-Thomson effect that is clearly mentioned. So we know this formula.
20 by 22. 20 by 22, madam.
Yeah, exactly. So let me write down the formula that we are using. So from here we are using del T upon del P at constant enthalpy. So what we are having, our temperature, so please keep your mic off while you are not speaking. Thank you. So this is your pressure, this is your temperature 1. Now your temperature fall to 20, that is your T2, and then okay, so now you have to keep your temperature, that is your del fell to this temperature is given, that is 20 Kelvin, and now the other quantity that given is your 1 atmosphere, that is del P for 1 atmosphere, 1 minus another is 22 atmosphere, that's given. So now what will be the answer? Minus 20 so it's
0.96, 0.96, madam.
Yeah, 0.96. Option B. So okay, everyone getting the same? Yeah, it's almost same, yes. We can round off to 0.96. Okay, moving to the next question. So here the bond dissociation energies of gaseous H2, Cl2 and HCl are given, that is 104, 58 and 103 kilocalories per mole respectively, and to calculate the enthalpy of formation of HCl gas. Okay, first let me write down the equation, then please try to solve it. So this is very simple equation, right? And it's forming your HCl. So balancing your stoichiometry, that is 2HCl. Okay, so the bond dissociation of this HH is given 104 kilocalories per mole. ClCl is 58 kilocalories per mole, and your HCl is 103 kilocalories per mole. Now we have to calculate the enthalpy of formation of HCl.
Answer B, madam, minus 22.
Yeah, it's answer option B, that is minus 22 kilocalories per mole. Okay, then let me solve it further. So now these values are for your H2 system, right? So now we have to take, for the formation of HCl we require one hydrogen and one chlorine, so we have to divide all the values by 2. So now taking half in, half outside, and the taking the dissociation, so now making, this is your dissociation energy, so I am denoting by D, right? So your dissociation value for, so you require HCl, that is you want the dissociation of this hydrogen and chlorine, and subtracting your overall energy of your of HCl. Why 2? So in the equation we are having 2 moles of HCl, right, in the right hand side. So now subtracting the 2 moles over here, right? So now putting the values over here, this is your 104.58 minus 103, 2 into 103. So this all will be your kilocalories per mole. So after calculating all, what we are getting? This is what we are getting, right? So here, so the change in moles, how we can find the final minus initial, right? So there are 2 moles and 1 mole from here, there will be 2, right? So your change in mole will remain 0. So instead of your PV, I am writing your delta nRT. So this term will be 0 whole. So that means, so your delta H is equals to your delta U. So whatever the value of delta U you are getting, that will be the value of delta H, that is minus 22 kilocalories per mole. So that is option B. Yeah, everyone getting option B? Okay. Okay, moving to the next question. Okay, this question states that the standard enthalpy of solution of AgCl in solid in water from the enthalpies of formation of solid and the aqueous ion given below. So these are the formation enthalpy of formation for Ag plus, Cl minus and AgCl, that's given. So now,
Madam, the answer is 80 kilojoules per mole, madam, first one.
yeah, exactly 80 kilojoules per mole.
It's
Exactly.
very easy and very clear.
Yeah, it's very easy. Exactly. So just write down the equation and you will get the answer by writing it down. It's just a addition and subtraction of all this value based on your equation. So your equation that you will get is, so this is, so in water your AgCl will be comes into the ionic form, that is Ag plus, and the Cl minus, that is in a aqueous part. So this is your solid, right? So it's converting it into the ions, and when you're putting it into the aqueous solution, that is water. So we have to find the enthalpy of solution, right? So enthalpy of solution will be your enthalpy of formation of your Ag plus, that is your aqueous one, this one, plus your delta formation yeah, for your chlorine aqueous, this one, and then subtracting your this value, AgCl, that is your solid. So now put the values in the same format and try to get the answer. So this is 100, yeah, 100, then it's minus 120, 120, and then subtracting your overall AgCl value, that is minus 100. This is your minus 100. So all the values are in kilojoule per mole. So this is an easy calculation. So after that, after calculating all, you will get 80 kilojoules per mole, right? So our option is A. Option A. So everyone getting 80 as your option A as the answer. Okay. Okay, good. Okay, moving to the next question. So it states that the given that the standard enthalpy of combustion of graphite is minus 393 kilojoule per mole, and the diamond is minus 395 kilojoule per mole, and the enthalpy of diamond to graphite transition is. So this will be easy part, right? Just a subtraction of these values.
Answer A, madam, 2 kilojoules per.
Yeah, exactly. So everyone getting the same answer? Yeah, I think this one was the easiest one. So this enthalpy of transition from graphite to diamond will be so it's option A. So everyone getting option A, right? Okay, moving to the next question. So we have given this Joule-Thomson coefficient over here, and then at 3000 degrees Celsius in the pressure range of 0 to 68 atm, the Joule-Thomson coefficient of nitrogen can be represented by the equation. This equation they have represented, and calculate H when 10 moles of N2, a van der Waals gas, expands isothermally at 3000 degrees Celsius from 45 atm to 30 atm, and the given Cp is 7 by 2 R. So this is the equation.
Madam, the answer is 19.424 joules, madam.
Okay. Can you please explain how you?
Yes, madam. Yes,
Yeah.
I'll tell you, madam, because here,
Huh.
first of all, we have that mu jet is equal to dou T by dou pH.
Hmm.
Then we have to calculate the dt,
Yes.
because dt is equal to mu jet into dp. And mu jet value you have given as 0.0142 minus 2.64 into P. So you have given the ranges, the initial pressure from 45 to 30 atmospheres, you have to integrate that first. So if you integrate it, you'll get the delta T.
Yes.
So integration value turns out to be, delta T value turns out to be 0.06675.
Okay.
Delta T value that turns out to be 0.06675 Kelvin. Once we know the delta T value, we can substitute in delta H.
Okay.
Delta H is equal to minus NCP into delta T, because delta H is equal to minus CP into mu JT into DP. Mu JT into DP becomes delta T now.
Okay.
Did you follow, madam? What I said?
Yeah.
So,
Sure. Yeah.
because mu JT formula is minus 1 by CP into dou H by dou PT. So therefore delta H becomes mu JT into CP into DP. But mu JT into DP by the above equation becomes delta T.
Okay.
So therefore the delta H, finally the
option
answer becomes 19.424.
Option A. Yeah.
Yes.
It's very much
Yes.
correct.
The only thing is we have to use both the formulas of mu JT. Mu JT is equal to dou T by dou pH. We have to use, first of all, to integrate that equation within the limits,
Yeah,
and to get the delta T value. Once we know the delta T value, then automatically mu JT into DP becomes delta T.
Yeah, exactly.
So CP into delta T into N moles. So that answer turns out to be this.
Option A. Okay.
This is very interesting, madam. This sum is very interesting sum.
Okay.
Thank you.
Okay, thank you. Okay, so we are having the equation. So this is what is given in the equation, and from here, for delta H at constant temperature, we can write it as minus Cp mu Jt into dP, right? And now our mu Jt value is 0.142 minus 2.6 into 10 to the power minus 4 Pascal. This is Kelvin per atmosphere, right? And Cp given is 7/2 R. And your pressure changes so one pressure change is this 0 to 60, and one is from 45 to 30. Now putting this equation over here, that was 0.0142 minus 2.6 into 10 to the power minus 4, right? Minus 4, that is Pascal, into Gp. So now this is your differential equation. So now we have given the pressure range. So now what we are doing, now integrating this equation from this, and now so now doing this integration and taking this term with this one and this term with this one, and then integrating with respect to this, that is subtracting the final minus initial values from here, that is 30 minus 45 atmosphere. And similarly for the second part also we are doing the same. Cp so here the term is P, right? So it will be that is your pressure, the pressure term, your pressure that will be after you integration it will be division by 2, and it will become p square. That the p square, the putting the value to the p square, that is initial minus final, that is 30 square minus 45 square, that it will become atm square. So this is your pressure. So while integrating it, you will get the integration of this one as a p2 upon 2, right? So similarly this is the value that we are putting over here, taking the 2 out, and then the making the square of your final and your initial pressures. Okay, try to calculate it. And your Cp given was 7 by 2R. So try to put this value over here instead of Cp. What we are getting. So I'm taking the Cp out of from all the equations. So this will be 15. So this will be again minus due to this one, minus how much? 260 into 10 to the power minus 4 divided by 2 into, so after making the square of this and subtracting the value, you will get 1125. Right, this is the value that you are getting after subtracting this 30 square and 40 minus 45 square. Okay, so now let me know the whole solution. Sorry, not from here, at least from here to here. How much the overall value you will get after solving this? So this is how much? This is how much after solving this?
Madam, that value is 0.06675, madam. 0.06675.
Sorry, which one you are talking?
This one only, the integration value you are talking, this
Okay, this one,
0.0114 to 15. Yes, madam.
Yeah. Okay.
That value turns out to be 0.06675.
Okay, 6675. Yeah.
Yes.
Okay.
Multiplied by Cp into number of moles.
Exactly. So this will be your Cp will be, this is your Cp, right? 7 by 2R. 7 by 2R. Now put this
Into number of moles, madam.
how many moles?
You have given 7 more. You have given 10 moles, madam. 10 moles are given, madam.
Okay.
10 moles of nitrogen.
Then what is the answer you are getting? 19.42. So how much answer after solving this?
19.423, madam, actually.
Yeah, 19.42. Okay. So everyone getting same answer, 19.42? 19.42, yeah. Yeah, here. This will be joules. Clear, right, this question? So shall we move to next question? Okay, this question states that the standard enthalpy of formation of phenol is minus 165 kilojoule per mole, and standard enthalpy of combustion is. Okay, so this is some sort of similar question that we have just solved before. So let me write down the equation. What equation is going to follow is combustion, right? So C6H5OH. So this is your liquid, and then your oxygen. Now in combustion, your CO2 is getting released, that is gas, and it's going to form your water. Now balance this equation. So balancing the equation is very important, because that stoichiometry is going to use in your further calculation. That is the number of moles that is being used up in this overall combustion step. So how much O2 is required here? Seven, right? Yeah, 7 moles. And how much CO2? And how much water? 6 and 3, right? This is what you are getting after balancing the equation. That is 6 carbon, total number of hydrogens are 5 and 6, and now making into 6, and then your oxygens are how much? 3 and 6 to 12, 15 oxygens are here, and here 7 to 14 plus 1 from OH, 15. So its equation is balanced now. So now we have to find the enthalpy of combustion. That is delta. Sorry, this is not the correct notation. So yeah, this combustion, right? CO2, and then adding your combustion, so adding your water, right? This formation of your water. How many moles are there? 3 moles. Taking 3 over here. And how many moles of CO2? That is 6. Taking 6. And now subtracting C6H5OH minus so this is 1 mole, right? This is 1 mole, and this will be your 7 moles. 7, right? So now put the values in the equation. So
Madam, the answer should be 1335, madam. It is not 3135 as given in the options. It must be 1335, madam.
1335.
Yes, madam.
Okay.
Please calculate, then you'll know.
Okay, fine. I'm just reaching there. Okay.
Okay.
So yeah, for your CO2 is how much? 400 plus 3, this 3, and your water, how much water? 300 again, minus 300, and now subtracting your C6H5OH, how much? Minus 165, minus 165, and overall how much? And subtracting your 7 into oxygen, that is 0, so this will be 0, 7 into 0, right?
Okay, madam, it's 3135 only.
Yeah, 3135, right? Yeah.
Yes, it is right, madam.
Yeah. Okay, after solving this you will get your option this, minus 3135 kilojoule per mole, right? Kilojoule per mole. So everyone getting same answer, right? Option D. Okay, option D. Okay. We have done this sort of question earlier also. So this is the final question that we are going to take in this class. So the question says, a sample consisting of 2 moles of perfect gas molecule for which the CV is equals to 5 by 2 R, initially at P1 equals to 111 kilopascal and T1 at 277 Kelvin is heated reversibly to 356 Kelvin at a constant volume, and we have to calculate P2, del U, Q and W. So there is a perfect gas molecule, that means it follows PV equals to nRT, right? So what we are having, N equals to 2 mole and CV is equals to 5 by 2 R, P1 equals to 111 kilopascal, T1 equals to 277, where volume is constant, that is V1 equals to V2, that is equals to V. So it's ideal gas. Can we use this equation P1V so instead of P I'm putting in the divisibility format, right? This is P1V upon P2V is equals to nRT1 upon nRT2. So V is a constant, so constant equations, N is also 2 mole keeping constant, R is constant, and now from here we will get P2, P1 into T2 upon T1, right? So now our values are, so pressure is 101 kilopascal into what is T2, 356 upon 277. So what will be the answer?
It is 142.6, madam.
Okay, yeah, 142.6. So rounding off, so I'm writing it 143. Okay, so P2 will be 143 kilopascal. Okay, so here is stated that there is no change in the volume, right? The volume is constant. So our work is 0. So while we are considering your volume is constant, so our work is 0. So we are writing the Q is equals to CV upon dt, and that is after integrating, this will be delta t, right? Yeah. So what is the CV? CV is pi by 2r, right? Pi by 2r. Pi by 2r. What will be the r? 8.314 joule per Kelvin per mole. And how many moles? How many moles we are having? 2 moles in the equation. So I'm writing 2 moles into the temperature difference. So what is the T2? 356, right? And T1 is 277 Kelvin, right? So what will be the value of Q?
It is 3.284 kilojoules, madam.
3.
Okay.
Okay.
0.284.
Okay.
3.284 kilojoules.
So I'm writing the value in joules.
Okay, 3284.
Yeah. Then it will be 3285.6 joule, right?
Okay.
So
right.
Yeah, this is in joule. Okay. So now this is your Q. Now for del U, what's written? You have to find del U, Q and W. So W we know it's 0 and Q we calculated, and for del U will be from the equation
Is
W
it
is equals to del U plus Q. From the same equation we can find out this, right? W is equals to U plus del U. So this is 0. So that means del U is equals to minus Q. Is this correct?
No, madam, both are same, madam. Delta E is equal to Q becomes. Because delta E is equal to Q plus W, W becomes 0, therefore delta E is equal to Q.
Yeah, delta E is equals to Q.
Q.
Exactly. So using this Q, so now the
Plus
value, so this will be your 3285.6 joule, right? So this is the same that we got for the Q, the same answer. This will be del U equals to del Q equals to this much joules, right? So everyone getting this answer, right? 3285.6. Okay. So next questions we will take up in our next session.
Madam, one small question, madam.
Yes, yes.
Madam, may I know which whiteboard you are sharing to engage this class?
This is a slide presentation more like.
In the Google Classroom, you are sharing this whiteboard, or somewhere whiteboard you are sharing in the Google Classroom?
Whiteboard, you mean to say my...
This one, madam. This one, the board which you are using for writing now.
Okay, for the writing, this is a Microsoft PowerPoint presentation tool.
Okay, Microsoft Whiteboard you are using, madam?
No, it says just a PPT. This is PPT.
Okay, Microsoft PPT,
Yes,
normal
yes.
PPT.
Yeah, normal PPT. I'm just writing on it. Yeah.
Normal PPT, Office 365 you're using?
Yes. Oh, yes, 365 exactly.
Office 365 you
Yes,
are
yes,
using.
yes.
Okay.
Yeah.
Madam, second question is that in the assignment 2,
Huh.
the sixth problem, I think that is wrong, madam. It is wrongly given, I think. The
Okay.
sixth problem, and then even in the 10th problem also,
Mm-hmm.
according to the data that is given, the option C is correct, but the option number is correct. But
Huh.
there it is given 4 kg of helium,
Okay.
weight of helium, but that doesn't tally the answer, madam.
Okay. Even
So can you
even
please
Sandeep
in this
also had
assignment too?
put the this query to the forum.
Yes,
I
I have
think
already put the query in the
forum.
mail also, madam. But
Yeah.
so far I didn't get any response.
Okay. Maybe
So
those are
can you
graded
please
ones, so they will take care of your grading part. Maybe. Yes.
can you please go through those questions and can you clarify that those two?
So right now I don't have those questions with me. So I
Okay.
have to log in and again download it to check it. Yes.
Yeah.
So I am taking
Because
forward the previous year questions, so it's not the recent year questions that have been given to you.
okay.
Yes.
So then who will clarify those two questions, madam?
Maybe the actual TAs who are working on this part, who are actually preparing your assignment questions, those are the one who are actually like taken care of all these questions and answers and the question formation.
Okay,
Yes.
right.
Yes.
So can you please at least ask them to do this clarification?
So it's better the problem that you are mentioning with your screenshot of your
So
question and everything, you put it on the forum.
yeah, okay. I already mentioned the numbers, question numbers.
Okay.
But the only thing is what I have not done was that I have solved it and then I have not
Mm-hmm.
get the screenshot of that and I didn't send the screenshot. That's
Oh,
it.
okay. Got it. If possible, try to do like put the screenshot over there, so it will be clear. It will be totally clear to them what is the issue that you are raising up.
Okay, I'll
Yeah,
I'll put the screenshot also then.
exactly. Because those are the actual TAs who are handling in preparing your questions and you are handling your answers and your assignment questions and everything.
Okay,
Yeah,
okay.
exactly.
Another question I
Yeah.
want to ask you, madam.
Yes.
That is the last question, of course.
Yeah, please.
Here, see, I want to ask one question that there are so many books on thermodynamics and chemical thermodynamics, especially
Exactly.
are there in especially in Indian editions or even some of the foreign editions.
Hmm.
See, the sign convention for the work done, they are taking it as work done as a positive for the work done by the system.
Hmm.
So work done by the system, W is taken as positive. But of course, as per the recent convention, which you are also following now, even the professor is also following the is opposite one. That is a recent one, of course.
Yeah.
But in the competitive examination, suppose if I am following the old convention, and suppose if the W value is equal to 42, let us suppose joules, I will write W is equal to plus 42 joules. And the person who is following the new latest convention, they'll write W is equal to minus 42 joules.
Okay.
Then how it is able to justify the answer?
This is the
So plus 42
same
is plus
problem that
42
I
is also
faced in my
plus
competitive exams
42.
too. Yes,
1 minute,
exactly. Yeah.
madam. Plus 42 is also correct as per my knowledge, and minus 42 is only, see, the magnitude is the same, but only the sign convention. So sign convention, some are following the plus sign, some are following the minus sign. That's the totally injustice that is being done to the students in this matter, I think.
Yes. I agree.
So I think within the brackets, when the problem is given within the brackets,
Hmm.
the examiner should give that the work done by the system should be taken as positive or negative as per the so-and-so convention. If that is given, then the option will be correct. So I think the examiner has to do that because many questions that are given in your assignment in the second one as well as in the first one. If I follow the convention that is there in the old convention, which many textbooks are even now following. If I do that, then all answers will be zero for me, as per
Okay.
your convention.
Okay.
So I'll get 0 mark instead of getting 100%.
Okay.
Then what is the solution for this? What do you think? What is the solution for this?
This is actually tricky to get the actual sign, but Yeah, Sandeep wants to say something. Yeah, Sandeep, you can get into the discussion. Yeah.
Ma'am, in case of physics, thermodynamics, na, the
Mm-hmm.
sign convention is opposite.
Yeah.
But those type of, but for us, IUPAC, what has recommended now, we have to take the work done by the system as negative. So whatever we are following is correct. Uh, but
No,
for
no.
physics case, it
See,
is opposite.
Mr. Sandeep, I am not saying that it is wrong. What I'm saying, I'm not saying that what these people are now the professor is following is wrong. I'm not saying that it is wrong.
No, no,
What I'm saying, no, no.
it is IUPAC has said, na, IUPAC has
Yes,
said,
yes.
and
IUPS, IUPSC,
Atkin is
yes.
also the member of, Atkin is one of the member of IUPAC.
I
So Atkin
agree.
go, yes,
I agree for that, Sandeep, Mr. Sandeep. I know, I don't know whether you're Dr. Sandeep or Mr. Sandeep. I'm sorry for it.
no, no,
But
I'm not
I
doctor.
agree. Okay, I agree for that, that it is IUPAC has given that. But if you go through the Marin and Proton, and even the standard books and even this
No,
thermodynamics by
no,
Gladstone.
those are old books, old books. Like
No,
I
no,
have
those
Castellan, na, Castellan, it is
Castellan also,
1973 book.
Castellan, and then
Yes,
Marin and Proton, and then
yes.
even thermodynamics by Gladstone, all those follows only the old convention.
Yes, sir. But because Gladstone is 1946 books and also Castellan is 1973 books. But IUPAC book na IUPAC recent convention that Atkins is following and other books are following like Mortimer
Yeah,
and
I agree.
other
I
books.
agree. I
So
agree that they're
so
following
yes.
this convention, but in my opinion, the answer should be given. Both should be given correct.
No,
Whether
no,
it is
both
minus or
cannot be
plus, it
given
should
now
be given.
because whatever why we are learning new IUPAC nomenclature. If there is no need of using the old convention itself, then what is the use of studying the
See,
new
this is the personal choice of the candidate. It's not hard and fast rule that you have to follow only the new rule. See, there are many Indian authors books are there. Even still, they follow many foreign editions. They're still following the old convention. So I think it is better to mention the sign convention when so and so problem is given in the examination. Then that will be fine. That's my opinion. That's it.
Yes, it's okay, uh, but
But
if
many see,
even
even there are so many faculty members are there who are following still the old convention for the work, because once they're following the new convention, see in some of the derivations, especially once they're following the new convention, some of the derivations there is a problem is arising. Some problems I can show you one or two examples in that regard. There are some problems are arising that the faculty members are still finding unable to explain that particular concept when they're following the new convention. I can quote some of the examples in that particular regard. So it is bad if you follow the world convention, then everything becomes very smooth till the end of the thermodynamics. So that's what I have experienced it.
yes, but for chemistry, I estimate something
No,
different.
I'm talking only in terms of chemistry. I'm not talking about physics.
Yes, but physics and
I'm talking
convention
about
is
see
still over.
this is the class with chemical thermodynamics. So let
Yes,
us confine only to the chemistry part.
yes. So in chemistry, sign convention is opposite. So this is the
Okay.
new and IPC convention. So
Okay, madam. Thank you
Yeah.
for your nice interaction.
Yeah. Thank you for your discussion and making the class more interesting.
Yeah,
Okay.
thank you.
Okay. Thanks all,
Thank you,
and we
madam.
will meet you in the next session.
Thank you, madam.
Yeah.
Thank you.
Next Friday from 6 to 8 p.m. And thank you all. Thank you.
Thank you. Thank you.